So for this problem, we are going to be finding maxes and mins over a closed interval, as well as finding the maximum and minimum values of the function. And we are going to be using the second derivative test on this one. So this one specifically is saying use the second derivative test. So in order to find our candidates for maxes and mins, so candidates for maxes and mins are critical points. So remember, that's where a function is has a derivative equal to 0 or undefined, and endpoints. So endpoints are also candidates for maxes and mins, okay? So let's go ahead and find our critical points. So S prime of t is equal to, multiply in front, 2t squared minus 6t plus 4. So let's find our critical points in order to find candidates for maxes and mins. Okay, so 0 equals 2 times t minus 1 times t minus 2. So t equals 1 and 2 are critical points. Okay, these are critical points. But we don't know if they're maximums or minimums. So let's use the second derivative test to figure out whether they are maxes or mins. So the second derivative is 4t minus 6. So the second derivative at t equals 1 is 4 minus 6, a negative number. And s double prime of 2 is equal to 8 minus 6, which is positive 2. I don't actually care about the numbers. I wrote them down, but what I actually care about is whether they are maxes or mins. So local max at x equals, or t equals actually, and I know there's a local max when a function is concave down and has a slope of 0. So where do we have a slope of 0 and our function is concave down? 1. So because s prime of 1 is equal to 0 and s double prime of 1 is less than 0. And that's it. That's your explanation for why you have a local maximum using the second derivative test. And then we have a local minimum at t equals 2 because s prime of 2 is equal to 0 and s double prime of 2 is greater than 0. So again, if you have a slope of 0 and your function is concave down, that's a maximum. A minimum is when your function is concave up and has a slope of 0. So that's why the second derivative test is important. It tells us concavity. So again, if our function is concave up and we have a slope of 0, we have to have both parts. One or the other is not enough to justify a max or a min. But if you have both parts, you can justify maxes and mins. All right, now it says it says find the local maxes and mins, which I found. And it also says maximum and minimum values. Okay, so I know at my endpoints something happens. So let's figure out what happens at your endpoints in order to figure out your absolute max and min values. Because if I have endpoints, like let's say I have a graph where like I have no absolute maximum. Okay, so I have something like this. Okay, there's no absolute maximum, but if I were to add endpoints, then one of my endpoints is the maximum value, right? And you could have something where like one endpoint is a maximum and it's not a local max. I have a local max here. I have what we call an endpoint maximum. And then here I have an absolute minimum. So there are lots of different kinds of maxes and mins. You can have endpoint maxes and mins, you can have local maxes and mins, and you can have absolute maxes and mins. Absolute maxes and mins are local or endpoint. Okay, so let's figure out what happens here. So I'm going to test all of my candidates. Remember, my candidates are endpoints and my critical points. So I'm going to test all my candidates. So I am only testing, so these are critical points and endpoints. Now, I wrote a nice example here where the endpoints are 0 and 3 and the critical points are 1 and 2, and it happens to be 0, 1, 2, 3. I am not testing these because the numbers are 0, 1, 2, 3. I am testing them because they are critical points and endpoints. That's the only reason, and it's a coincidence that they happen to be 1 unit apart. Okay, now if I plug in 0, I get 0 minus 0 plus 0 plus 1. If I plug in 1, I get 2/3 minus 3 plus 4 plus 1. And I'm not even going to simplify it right now. Okay. If I plug in 2, I get 16/3 minus 12 plus 8 plus 1. And if I plug in 3, I get 27/3, which is 9. 9 times 2 is 18. I know I'm going through this quickly. You can pause the video and go back and double check my math. Minus 27 plus 12 plus 1. All right. I'll simplify these a little bit. This is going to be 2/3 plus 2. This is going to be 16/3 minus 3. So 16/3 minus 3. And this is going to be, let's see, negative 9, so plus 13, which is 4. Okay, so I've got 2 and 2/3. I've got 1. I've got 4. And then 16/3 minus 3 is 16/3 minus 9/3. So that's 7/3. Okay, so my min value and my max value. So the word value means the actual like y coordinate, like the value of the function. So what's my lowest number? 1, 2 and 2/3, 7/3, or 4. My lowest value is 1. So that's my minimum. And then what's my maximum? So 7/3 is 2 and 1/3. So 4 is my max value. Okay. So what that means is this graph, let's see, I have a absolute minimum at 1. I have a local max. I'm sorry. I have a minimum value at 0. I have a local maximum at 1. Then I have a local minimum at 2. And then I have an absolute max at 3. So my graph looks something like this over the closed interval based on all of this information together. So I have endpoint maxes and mins. They are the absolute maxes and mins. I also have local maxes and mins. And again, I want to point out that in this particular case, my critical points and endpoints happened to be the numbers 0, 1, 2, 3. That does not always happen. And this one happens to be that my endpoints are the minimums and maximums, the absolute min and max. But it is possible that your graph looks like, like this, where like the absolute maximum is a local max as well, or my absolute minimum is a local minimum as well, or something like that. So I just want to point out that just because some certain things happen in this example doesn't mean they always happen. That's why it's important that you understand the process. And again, if you're finding max and min values, just plug the candidates into a T-chart to find those out. Okay, you have to figure out what your candidates are first, which are critical points and endpoints, and then you can make a T-chart to check.